Hello everyone. I'm going to talk a little bit about vectors in the coordinate plane. Specifically, there are two concepts I want to look at here. One is the component form of a vector, and the second is the magnitude. So the component form of a vector it's another way to write the vector. It's another way to express it, requires a little bit less notation, and it gives us all the information we need about that vector. The second thing is the magnitude, and the magnitude of the vector, remember, is the length of the vector. Okay? Now, both these things are relatively straightforward processes. All we're going to be doing here is we're basically just using the vector to create a triangle, and then we can use that triangle to find the information we need. Okay, so the component form of a vector looks something like this. So we have vector initial point A, terminal point B, so notation, so vector A, B like that. And this is going to be equal to, we have these pointed brackets, and for now I'm just going to say A, B. And these two variables in here, this A, this is going to tell me the horizontal change in my vector, so how far left or right the vector has to go. And B is going to tell me the vertical change, okay, how far up or down. So here I'm given the 2 points. Let me just sketch these out so we can think about this for a second. So nothing too fancy. So -4, 2, so maybe that's over here. And then our terminal point, 3, -5, it's somewhere down here. Definitely not being exact by any means. Okay, and we're starting at A, and then we're going to B. To fill out my component form, what I need is how far left or right this goes, and then I also need how far up or down. So if we imagine drawing in this little right triangle, what I need to figure out is this horizontal distance and this vertical distance. So like that would be A, and this would be B. Okay? Now, to figure that out, whenever we're looking at horizontal or vertical segments, we can think of the length of those segments as the difference of the x values, or the difference of the y values. So this length, this is just the difference of my two x values, and this length is just the difference of the two y values. So in other words, the component form of a vector is my two x values subtracted and the two y values. The only thing that we need to be careful of is x2 and y2. Those have to be my terminal point. So this has to be x2, y2. And the reason we have to be careful with that is just so that we have our vector pointing in the right direction. If I flip these around, my vector would actually be pointing the other way, which we don't want. So for us, we have, let's see, so our two x values, 3 minus a -4, and then the two y values, -5 minus 2. So AB, the vector, is equal to 7, -7. So then what this tells us is it goes +7 in the x direction. So starting from A, we need to go +7 horizontally. And then -7 for the y value means that we go down 7. So from A, we go down 7 to get to there. So +7, -7 gets us to the terminal point. Okay, so let's take a look at the magnitude. And again, we're just going to relate this back to triangles. So the magnitude of a vector is its length. If I can find the component form of this, I would know the horizontal and vertical change. And to find the length, we have a couple different options. So one of those options is the distance formula. right? So the magnitude, just another word for length. So if I find the distance between these 2 points, that's the magnitude. That works. However, I just want to discuss a little bit of a different way, something that's more useful with vectors. Again, let me just sketch this out. So -2, -7, maybe that's way down here, and then 6, 1 for the terminal points. All right, let's start off by writing the component form for this vector. So just like we did above, the difference of the x values, so 6 minus -2, and then the difference of the y values, 1 minus -7. So our component form this is the vector 8, 8. So we need to go 8 in the x direction, 8 in the y direction. So if I think about that, that's +8 horizontally. And then we need to go +8 vertically. If I draw that in, you can see we have a triangle, and it's a right triangle. So if I want to find the magnitude of this vector, I can just use the Pythagorean theorem. So we would do 8 squared plus 8 squared is equal to the length of the hypotenuse squared. We're going to end up taking the square root to solve this. So our formula for finding the magnitude of this vector is the square root of just a squared plus b squared. So a and b are both 8. So 8 squared plus 8 squared. And then solving this gives us the length. So that's 64 and 64, which is 128. But we can simplify that. So our magnitude, this is 64 times 2. If I split that up, the square root of 64 is 8. So 8 times the square root of 2. So here we go. 2 important concepts, 2 important things so that we can work with vectors in the coordinate plane.